Welcome back. In this video, we will try to practice some of the packages that we learned a little bit about in the previous video with a real-life example dataset. So our dataset would be on a study that aimed to assess the prevalence of depression and the association between academic motivation and depression in medical students at Hanoi Medical University. So it's a cross-sectional study conducted on around 500 medical students from like 2015 to 2016. We use a random sampling technique to select all the participants from the sampling frame, and all of them were asked to complete a questionnaire including demographic, socioeconomic status, patient health questionnaire to assess their depression symptom, academic motivation scale to assess their academic motivation, and the international physical activity questionnaires. So in this study, we found like the prevalence of depression is around 15.2%. And then you can read more about this study with this link. Before we begin, I want to make sure that you have already downloaded the two files that I sent along with this video. The first one was the clinical learning survey data.dta. So that was like a dataset file for our practice. The second one was creating table.do. So it's a do file that holds all of the example codes that I created for today. So if you already have Stata installed in your machine correctly, you just click on the do file and it will open Stata for you. Here, it opens Stata for me with like the do file and also like the Stata console. So what I'm going to do is that like normally I will like divide this program into like two separate half of the screen for me to easy to see everything here. And then I will turn off the review one to have more working real estate. And then I can increase the front here by using Control and my mouse wheel. Here, let's learn a little bit about a do file. So with a do file, normally I will write a do file that will be able to help you to analyze your data from start to finish without any kind of interruption. And normally with the do file, you can add note to let other people understand what you are trying to do, or if your student are analyzing data, he or she can add note and let you know like what he or she trying to do, so you can be able to double check what they are doing. And then like it would be very helpful for reproducible research later that you need to rerun an analysis, or if you have more data and you want to reproduce some of the old analysis in the past, or you have a new project, you can copy some of the code from an old project and get the analysis going very fast compared to using the click and searching to the menu like SPSS or like what you normally do with Stata. So to start, when do file, normally I will have a note to remember the purpose of this program, of this do file. So in here I write like the purpose of this program is table creation. I can use this symbol to let Stata know this is a note for myself. Everything is a note in Stata will display as red in the do file. And here I note for myself, always remember to load a dataset in the working directory before cleaning or doing anything with the data. So it's just a note for myself. We will learn more about working directory down below. And then I have some preparation code. At the beginning of a do file, I have clear on let Stata know this beginning a new session, clear everything from their memory. And then like I have set more off. So with the old Stata in the past, like they will not automatically run onto the code. Like they will run like to one screen and you have to click see more. But now with new Stata 14 or higher, you don't really need set more off, but I put the code there. So if as a pupil use older version of Stata, can still like analyze the way I do. and I have like set line 255. So the last data knows that I want each line of code have 255 characters. So it will be very wide, spanning like all the way through the result console. Set type double is like a code that lets data know that I will want to store all kind of number at a double variable. So they will use 2 bits of memory to store that variable rather than 1 bit with a float variable. And then like macro drop on is just like a different code to let data know to drop all of the macro. So if you do data programming, you will know more about macro, but in here you don't really need to understand more about macro. But like these codes are very helpful to get Stata working in a correct way and make sure Stata is in the best prepared state for you to begin to analyze your data. You can add more code to the preparation section as you go, like to set up Stata as you want beginning of the session. Now coming to working directory. So if you have learned about computer in the past, maybe like learn about the old Microsoft DOS or like NC in the past, you might know like something about working directory. So simply a working directory is where you will work within your program. So like if you create a table, it will save in the working directory. If you create a figure, it will go into the working directory. So you don't have to go around your computer to look for the table that you just created, or go around the computer to find like where should you put your data set. So a working directory would help you to accomplish all of that. So first, you have a command to check your current working directory. So you can select this command and then like click Ctrl and D to run the command, or you can select the do button after you select that, and then like it will run the command into the Stata console here. Normally you can select and Ctrl D and it will run the same, or you can select do. One of the nice things about Stata is that like you can select a bunch of code and execute them at the same time. Or if you don't select any code and you click do, they will run all the code from the top to the bottom. So normally I will try to select the bunch of code that I want to run, that I just want to run. In here I have my working directory here. So in order for you to get a correct working directory in this practice, you can check for your working directory. Normally it could be like the working directory that you are currently saving these two files. And then you can copy that and you will put your working directory in this line. So I will delete this. I will put my new working directory here. And then when like you run this code, Stata will know your new working directory. So you can see here the working directory have already changed. And then when you have already set up your working directory, you can load the dataset with a very simple code, use and the file name, or then the subfolder and the file name. You don't have to type in a very long like file address anymore. For example, I can click this and I can load my dataset. You can see here all of the variables have already been loaded. Next thing that I want to do is that like to set a log file. Or this will reset the path if you did not set a working directory. Remember, always to set your working directory first. So I have a line here, capture log close. The capture log close command will help you to close any log files that are currently opening. So you don't like accidentally double like writing a new log into an old log file. So it will close everything for you. And then I will log using analysis.log and replace. So if there already a log file named analysis.log, it will replace, override this old file. Let me run this code. Okay, so a new log file has been opened. This is like the file address of the log file. So like there haven't been any log file there, so it will continue to write a new one. If there was one file, so it will have a note that like they will override this. For example, if I rerun the code again, you can see that here they will be log replace. They will not have a note that like there was no log file like the previous one. And then one of the very next code I always run in my do file is Codebook. So Codebook will help you to have a sense of the data. For example, if I run the Codebook, you see here they print out a bunch of output. You could see here, this bunch of output will talk about like all of the different variables that we have in our dataset. For example, it will let you know that A01 is gender. And with gender, we have these are a numeric variable. It has a label that is gender. And the range is 1 and 2. With unique value is 2 unique value. With no missing. And then like they also generate a simple table for you to understand that like value number 1 is male, second is female with frequency. And then the next one is A06, it ties how mess. And this is also a numeric variable with like 1 is living with family, 2 is living alone, 3 is living with a roommate. A14 is fail at least one clinical exam in medical school, with 1 mean no and 2 mean yes. And A15 is fail at least one theory exam in medical school, 1 also mean no and 2 also mean yes. Level of English reading skill, with 1 is basic, 2 is independent and 3 is proficient. And we have number of night shift per week, like 0 is less than 2 and 1 is more than 2. And we have another variable like having to do 11 work in the night shift, with 0 mean no, 1 mean yes. And then we have like depression symptom, with 0 mean like they don't express any depression symptom, and 1 mean yes, they have some depression symptom. And then we have learning motivation, with 0 mean none self-determined motivation, and 1 mean they have self-determined motivation. So that is like the basic with all of the codebook. Like you can run the codebook with all the datasets. All of the dataset, you just type codebook and it will print out all the codebook for the entire dataset. Or you can do codebook by variable. For example, here I can type codebook with a variable A01, and then I run that command. It will only print out the codebook for that variable alone. Okay, coming to the next session is installing the package that we have already talked about. In here we have table 1, table 1 MC, tab out, very other package that we have briefly talked about, base table, RF and SL. So in here we have a code that will help us to automatically install the package if you have not installed them. So capture week and the name of the package will have to capture if your computer already have that package, and if like the computer return a error, like the number of error code is 111, it will automatically tie in the etc install and the name of the package to automatically install that package. And like this code was like created by other people online, so I have a credit for them. In here you can read more about this code if you want to. So it would be very easy to have that code at the beginning of the do file, so it will help you to make sure that if you transfer that do file to a different member of your team, they would be able to automatically install all of these packages without you have to remember to tell them which package to install. I will run all of this. Yeah, because like I have already installed this package, so they will just run and will not have any output to it. If this is the first time you install this package, they will like begin the installation process. And then I have another code to update all the package to their newest version. It is very independent from like updating Stata, so you don't have to worry about that.